conservation is the practice of using less energy. This can be done by making changes to our behavior, such as turning off lights when we leave the room or unplugging electronics when we are not using them. It can also be done by making changes to our homes and businesses, such as installing energy efficient appliances or insulation. As a result of energy management, both money savings and energy conservation have been made. Like, share, and subscribe. Thank you. The critical understanding of energy conservation requires the knowledge of thermodynamics. With it being said, the first law of thermodynamics, also known as the law of conservation of energy, states that energy cannot be created or destroyed in an isolated system. In other words, the total energy of a closed system remains constant over time, while energy change forms, such as from potential to kinetic or from thermal to mechanical. The total amount of energy within the system remains constant. This principle is a fundamental concept in physics and has broad applications in various fields, including thermodynamics and engineering. Understanding the concepts of conservation of energy. All instances used in this course are approached to understand the concept of conservation of energy. It will not be discussed in detail and should not be taken as a critical part of this course, as the system concept will be discussed in detail in our own course. Take for instance, when you put your phone into the wall to charge it, electrical energy from the supply in your house travels along the wire and it is transferred to the chemical energy stored in the phone's battery. Then, when you use your phone, the chemical energy is converted back to electrical energy, which flows along the circuits in your phone and powers the different parts like the screen and the speaker. In the screen, the electrical energy will be converted to the light energy so that you can see it, and the speaker will be converted to the sound energy. Ideally, every time the energy is socially transferred, it will all be transferred into a desired store that you want it to go to. In reality, though, some of it is going to be dissipated as wasted energy, which means the form other than one intended. This wasted energy is generally in the form of heat, which is why your phone might warm up a bit when you are charging it or when you are using it a lot. But remember, it can be in other forms too, like sound energy. Conservation of energy. If a given amount of energy is followed through various changes, you find that its total energy does not essentially change. The law of conservation of energy states that the amount of energy in the universe is always the same. It is possible to get only as much energy out of a machine as you put into it. In practice, output energy in a usable form is always somewhat less than the input. A portion of useful energy is usually wasted as heat in overcoming friction. Losses of this type prevent machinery from operating endlessly or from having perpetual motion. In effect, energy is neither increased nor decreased, but can only be changed into another form. The pendulum illustration demonstrates the law of conservation of energy. When the weight or bob of the pendulum is moved from its resting position at point B to point A, work is being done. At point A, the bob has attained a certain amount of potential energy due to its new position. Releasing the bob causes it to swing back to position B and on to position C. The potential energy stored at point A is transferred into kinetic energy as the bob passes point B. Upon reaching point C, kinetic energy is transformed momentarily into potential energy again. This is in turn again transformed into kinetic energy as the bob moves from C to B to A. The pendulum would in effect swing back and forth forever if it were not for the energy loss through friction and resistance of air. Overcoming these losses causes some energy to be transformed into heat. In a sense, the initial applied energy does not change in value, but appears in a different form. Careful study of previous examples reveals that when energy of one form disappears, other forms of energy appear in equal amounts. The operational equipment of building is directly related to this law. In effect, we are very concerned with operation being achieved with a minimum of energy loss. Efficient equipment operation with reduced energy losses will help to keep the world's supply of useful energy in proper balance. The impact of energy consumption on the environment. Climate change. Long-term changes in temperature, precipitation, wind patterns, and other aspects of Earth's climate system. This may have resulted from increased greenhouse gas emissions. Air pollution. It involves the presence of harmful substances in the air, including pollutants like particulate matter, nitrogen oxides, sulfur dioxide, carbon monoxide, and volatile organic compounds. Combustion of fossil fuel, industrial activities, vehicle emission, and certain natural processes contribute to air pollution. Water pollution. Contaminants such as chemicals, nutrients, heavy metals, or pathogens are introduced into the water bodies, degrading the water quality. Agricultural runoff, industrial discharge, improper waste disposal, and untreated sewage are common sources of water pollution. Land pollution. It involves the degradation of Earth's surface due to the presence of hazardous and non-hazardous waste materials, improper disposal of solid waste, industrial activities, use of pesticides and fertilizers in agriculture, and landfills contribute to the land pollution. The benefits of energy conservation. There are many benefits of energy conservation, which may include reducing our reliance on fossil fuels, reducing pollution, conserving natural resources, reduce greenhouse gas emission, and help mitigate climate change, improve air quality, and save money. You can ask me any question, or if you have any contribution, by commenting below or email me on joe.varsity1@gmail.com. Please, if you find this helpful, do not hesitate to like, share, and subscribe. Thank you.